Okay, hi grade 11. I'm just going to go over, sorry, let's move this out of the way. I'm going to go over how to do question 3 from the IB questions, the trig IB questions. So, part A, we're given a quadratic here, and we're asked to first of all find the value of x that gives a maximum value of y. So the quickest way, if we're not using technology, of course we could graph it and find that maximum. But otherwise the quickest way is to find the vertex. So we know that x equals minus b over 2a. And then just substituting in, excuse me, b is 160, so we have minus 160 all over 2 times minus 16. When you put that into your calculator, you get 5. So a maximum occurs when x is 5, and then the second part of the question asks you to find the actual maximum value of y. So now we just substitute 5 in. So we have y equals minus 16 times, substitute your value of x that gives the maximum. So times 5 squared plus 160 multiplied by 5 and minus 256. Oops. Minus 256. All right. And then that's just a matter of putting it into the calculator, and when you do that, you get y equals 144. Okay, so that bit was reasonably straightforward, and as you can see, obviously no trig. However, remember with these long questions that the parts often relate to each other, so keep that in mind for later on. So now we have a triangle XYZ. We have some various measurements, as you can read, and we know the perimeter is 16. And so the first part asks us to express z in terms of x. So this means we should have z equals some expression that has x in it. Now use what you know. We know the perimeter is 16. So think simple here. So we know that x plus z plus 6 must equal 16. And then just make z the subject. So subtract 6, so we get 10. Subtract the x. There you go. We're done. We've expressed z in terms of x. Excuse me. Part 2 asks us to use the cosine rule to get an expression for z squared in terms of z and cos x. So we want it to say z squared equals, and so therefore we use the opposite angle there. We use the z. And so we have z squared equals, and then the other two sides that form the angle, remember, because I need a sandwich, x squared plus 6 squared minus 2 times x times 6 times cos z. Let's just tidy that up a little bit. So we have x squared plus 36 minus 12x cos z. Okay, and that should be sufficient. It just says write an expression. So we're done. Now, hence, show that cos z equals that. So the word hence is always referring to then the previous part, and doesn't say hence or otherwise, so that implies that we have to use this part. So we want an expression for cos z. So I need to make cos z the subject first of all, using this from part 2. Oops, sorry, this is part 3. Okay, so what I'm going to do, I'll just erase that. Let's try and make from part 2, let's make cos z the subject. So to start with, we'll have z squared minus x squared minus 36 is equal to minus 12x cos z. And then just divide by minus 12x. So cos z equals z squared minus x squared minus 36. Oops. That's a pen. All over minus 12x. Now, I'm not finished because if I look what I'm trying to get to, here I've got cos z as a subject, that's a good start, but this only has x's in it, and I have this z. So we need to try and replace this z squared. And again, remember, the parts are always related to each other. Up here in part 1, we have an expression for z in terms of x. What we're trying to show only has x's, so we can replace the z squared with 10 minus x all squared. So we've got 10 minus x all squared minus x squared minus 36 all divided by minus 12x. And then it's just a matter of playing with the algebra to simplify that. So expanding the 10 minus x squared, I get 100 minus 20x plus x squared. And then minus x squared minus 36 all over minus 12x. And then we just have to tidy it up to try and get what we're aiming for. I just move this down a bit. Okay. Let's check. Alright, so just quickly then tidying this up. Tidy the numerator up, so 100 minus 36 is 64. The x squareds cancel out, so minus 20x all over minus 12x, and then just divide through by minus 12, because what we're trying to get to in the bottom is a 3x. So that tells me that these obviously can both be divided by 4. So I've got 3x in the numerator, so I can divide every single term by 4. So 64 divided by 4 is 16, minus, because I'm dividing by minus 12, so it'll become minus 16, and then that'll become plus 5x. And then finally, if you want it to look exactly the same, just switch it the other way around. So 5x minus 16 all over 3x. And we're done. Okay, so that's the first 2 questions done.